Hello! In this video I want to talk about resistor circuits, about the theory and how to calculate. See you after the intro. Today we want to talk about the series connection of resistors, the parallel circuit, and a network with a lot of resistors and how to calculate them. First we want to talk about the series connection of resistors. Here we have R1 and R2, and the total resistance is the resistance of R1 plus the resistance of R2. We can compare it with the water model. Here we have the conductor, which is a very thick pipe which has no resistance to the water, here and here and here. And the resistance are small pipes, and if the pipe has the same diameter, we have some water resistance here, and due to the fact that this pipe is double length, the resistance to water of this pipe is the double. If we now remove this thick pipe which has no water resistance, then we connect them directly and we have a pipe of the length of 3. So we have a water resistance here plus a double resistance here is in the sum 3 times water resistance. And that is the reason for the formula of total resistance is resistance 1 plus resistance 2. In the general rule, the total resistance is the sum of all the individual resistances of the serial connection. So R1 plus R2 plus ... plus Rn. Before we start with the parallel circuit, we need to introduce the conductance. Conductance is the measure how good electricity is moving from one end to the other end of a resistor. It is reciprocal of the resistance. The formula is G is 1 divided by R, and the unit is Siemens, or the short form the uppercase S. And of course it is also in the other way around. The resistance is the reciprocal of conductance. The formula R is 1 divided by G, and the unit of the resistance is ohm, or the lowercase omega. If we have a parallel circuit of two resistors with conductance G1 and G2, the total conductance is G1 plus G2. And of course also here the water model helps to understand. We have here the low ohmic conductors here and here, which are in the water model very thick pipes here and here, and the two resistors G1 and G2 with the conductance here and here, and these pipes are rectangular pipes with the same depths, and this has a width of 1 and this has a width of 2, so this is double conductive than this one. And if we want to know how is the sum of it, we bring them together, remove this border, and we see the water can flow in this part with conductance 1 and 2 times the conductance here with a broader area, and finally we have 3 times conductance, so it's the sum of both. So the total conductance is G1 plus G2, or the general rule is the total conductance is the sum of every single conductance in a parallel circuit, which means G1 plus G2 plus ... plus Gn. Now we come back to the parallel resistor circuit. We replace the conductance by the reciprocal of the resistance and write instead of G total 1 divided by R total, instead of G1 1 divided by R1, and instead of G2 1 divided by R2. The general rule for n parallel resistors is the reciprocal of R total is the sum of each individual reciprocal of the resistance, or 1 divided by R total is 1 divided by R1 plus 1 divided by R2 plus ... plus 1 divided by Rn. There is a special formula for two parallel resistors. I will show how to come to this formula. We know 1 divided by R total is 1 divided by R1 plus 1 divided by R2. So we extend the first term with R2 and the second term with R1. And then we get 1 divided by R total is R1 plus R2 divided by R1 multiplied with R2. And now we make the reciprocal of the complete formula and get R total is R1 multiplied with R2 divided by R1 plus R2. This formula was very helpful in the past because you have only one division. In modern time with pocket calculators, the root form is more practical because you only need to type in resistor R1 and make the reciprocal key plus resistor R2 and the reciprocal key, the equal sign, and again the reciprocal key, and you get the result. Now we will do some exercises. The first two exercises about the serial connections of two resistors R1 and R2 and the total resistance R. In exercise 1, resistance of R1 is 1000 ohm and the resistance of R2 is 4700 ohm. How big is the total resistance R? In exercise 2, the total resistance is 20,000 ohm and the resistance of R2 is 5000 ohm. How big is the resistance of R1? Press the pause button and do the math for yourself. Here's the solution. R is R1 plus R2 with concrete numbers. R is 1000 ohm plus 4700 ohm. So total resistance R is 5700 ohm. In exercise 2, R1 plus R2 is R. We bring R2 with minus sign on the other side. With concrete numbers, R1 is 20,000 ohm with minus 5000 ohm. R1 is 15,000 ohm. In the next two exercises we have two parallel resistors R1 and R2 with the total resistance R. In exercise 3 the resistance of R1 is 1000 ohm, the resistance of R2 is 4000 ohm. How big is the total resistance R? In exercise 4 the total resistance should be 6000 ohm. The resistance of R2 is 10,000 ohm. How big should be the resistance R1 to get the 6000 ohm total resistance? Press the pause button and do the math for yourself. For the solution of exercise 3, I will show it one time with the special formula for two parallel resistors R1 and R2. R is R1 multiplied by R2 divided by R1 plus R2. With concrete numbers, R is 1000 ohm multiplied with 4000 ohm divided by 1000 ohm plus 4000 ohm. R is 4 mega ohm square divided by 5000 ohm, and the final result for the total resistance is 800 ohm. For the solution of exercise 4, I will use the reciprocal formula. 1 divided by R1 plus 1 divided by R2 is 1 divided by R. We bring 1 divided by R2 with minus sign on the other side. With concrete numbers, 1 divided by R1 is 1 divided by 6000 ohm minus 1 divided by 10,000 ohm. 1 divided by R1 is 0.1667 millisiemens minus 0.1 millisiemens. 1 divided by R1 is 0.0667 millisiemens, and the final result is the reciproc of it, that R1 is 15,000 ohm. In our last exercise, we have a network with 4 resistors, R1, R2, R3, R4, which are sometimes connected in parallel, sometimes in serial, and again in parallel, and the total resistance R. The exercise is the total resistance R should be 5000 ohm, the resistance of R1 is 10,000 ohm, the resistance of R3 is 3000 ohm, and the resistance of R4 is 6000 ohm. How big is the resistance of R2 to reach the 5000 ohm total resistance? Press the pause button and do the math for yourself. For the solution, we replace in a first step R2, R3 and R4 by its total resistance R234 and get the parallel circuit of R1 and R234 with the total resistance R. Now we can say 1 divided by R1 plus 1 divided by R234 is 1 divided by R. We bring now 1 divided by R1 with minus on the other side. With concrete numbers, 1 divided by R234 is 1 divided by 5000 ohm minus 1 divided by 10,000 ohm. 1 divided by R234 is 0.2 millisiemens minus 0.1 millisiemens. 1 divided by R234 is 0.1 millisiemens with the reciprocal R234 is 10,000 ohm. In the next step, we calculate the total resistance of R3 and 4 and call it R34. Then we have this parallel circuit, total resistance R34 and R3 and R4 in parallel. 1 divided by R34 is 1 divided by R3 plus 1 divided by R4. With concrete numbers, 1 divided by R34 is 1 divided by 3000 ohm plus 1 divided by 6000 ohm. 1 divided by R34 is 0.333 millisiemens plus 0.1667 millisiemens. 1 divided by R34 is 0.5 millisiemens. With the reciprocal, R34 is 2000 ohm. In our last step, we have the serial connection of R2 and R34 with the total resistance R234. We can now write R2 plus R34 is R234. We bring R34 with minus on the other side. R2 is 10,000 ohm minus 2000 ohm. R2 is 8000 ohm. So with R2 8000 ohm, we get the total resistance of the circuit of 5000 ohm. That's all for today. If you like my video, give me a thumbs up and subscribe my channel. And to be informed about new videos, activate the bell. Bye bye.